Now let's take some theoretical aspect of this. Let's say if I have x plus y is equal to 5 and 2x plus 2y equal to 10. Solve this. Now here what will happen? Here if you see x plus y equal to 5, if I simply multiply it by 2, I'll get 2x plus 2y. From here I'll get 2x plus 2y equal to 5 into 2, that is 10. And the second equation is also same, 2x plus 2y equal to 10. So if I add, there will be no difference. If I subtract, it will become 0 equal to 0. Now what will happen here? What does this mean? This actually means that the equations are not independent. Why? Because you don't need to do any of these things. Just look at this carefully. If I just multiply the first equation by 2, I will get the second equation. So whether the second equation is given or not, it doesn't make any difference. Right? So actually, it does not require to be given. But that would mean we'll have only one equation. And whenever we have one equation in two variables, there will be infinite solutions. Right? Oh, so if I have two equations like x plus y equal to 5 and another equation just a multiple of the first equation, then it is simply infinite solutions. Okay. Let's take another situation. If I have x plus y equal to 5 and 2x plus 2y equal to 9. Now what will happen? Now this is a very tricky situation. This situation is not even correct. Why? Let's see. See, understand, these are simultaneous equations. Okay, so they have to be correct together. Then only we can solve. Whatever value of x and y we calculate, it should satisfy both the equations. Okay. So if I take x plus y equal to 5, 2x plus 2y equal to 9, they cannot go together. They cannot exist together. Because if I multiply this equation by 2, I'll get 2x plus 2y equal to 10. Whereas in this case, it is given 2x plus 2y equal to 9. So this is itself wrong. Now this situation is called system of inconsistent equations. They are not in coherence with each other. They cannot coexist. These equations cannot be correct simultaneously. Right? Now, if they cannot be correct simultaneously, that means there will be no value of x and y which will satisfy this. So we say no solution. Right? And this situation, this system of equation is called inconsistent equations. Just an English word. Inconsistent equations. Right? So here what I'll do, I'll just introduce the theoretical part of it. Okay. If there are two equations given, you can directly formulate your rules like this. For two simultaneous equations. Simultaneous equations. Let's say the equations are a1x plus b1y equal to c1 and a2x plus b2y equal to c2. Alright, look at this very, very carefully. First case, if a1 upon a2 is not equal to b1 upon b2, please pay attention. It says a1 upon a2. Now what is a1 upon a2? It is the ratio of coefficients of x. Coefficient means the number that is being multiplied to the variable, right? Coefficient. Coefficient is the number which is being multiplied to the variable. So the ratio of coefficients of x, if it is not equal to the ratio of coefficients of y, then in that case, you will always have a unique solution. So then the system is consistent and we will get unique solution. Okay, unique solution. So there will be one particular value set of x and y which will satisfy this unique solutions. But suppose in case a1 upon a2 is equal to b1 upon b2, then what? Now there is a problem. Now we need to check c1 upon c2 also. See, understand, when a1 upon a2 was not equal to b1 upon b2, we do not need to check c1 upon c2. Irrespective of their value, there will be a unique solution. But if a1 upon a2 is equal to b1 upon b2, we need to check c1 upon c2, then we will have two cases. So here, let's say first case, if it is also equal to c1 upon c2, then what will happen? Right? In this case, the equations will become non-independent. The equations will become same, that is this situation. Okay. Okay, so if A1 upon A2, like in this case it is 1 upon 2, 1 upon 2, 5 upon 10 is also 1 upon 2. Right? So if A1 upon A2 is equal to B1 upon B2 is equal to C1 upon C2, then infinite solutions. Infinite solutions. Right? So there will be infinite solutions for such equations. And finally, if we have A1 upon A2 is equal to B1 upon B2, right, but not equal to C1 upon C2. In this case, what will happen? This will become an inconsistent system. So this will be the situation of no solution. Okay, so there will be no values of x and y which will satisfy this equation. Okay, so just memorize these three conditions together. A1 upon A2 not equal to B1 upon B2, unique solution. A1 upon A2 equal to B1 upon B2 equal to C1 upon C2, infinite solutions. These two situations together, these two first and two second case together are called consistent system of equations. Obviously, consistent system of equations, right? At least the equations exist together. Whereas the third one is called inconsistent because there is no situation which will satisfy this. So it is called inconsistent system of equations. Okay. So for example, there can be a direct question on this. Suppose we have this equation 2x minus 3y equal to 6, 3x plus py equal to 9 has infinite solutions. Infinite solutions. Find p. This is the question. Right? So we already know the formula or the rule for infinite solution, that is ratio of coefficients of x equal to ratio of coefficient of y equal to the ratio of constant terms. So we can directly apply here. Look at the coefficient of x, 2 and 3. So 2 by 3 should be equal to here. Coefficient of y is minus 3. Be careful about the sign. And coefficient of y here is p. So it is minus 3 upon p is equal to 6 upon 9. Right? So first check whether 6 upon 9 is the same or not. If 3 cancels 6 2 times and 9 3 times. Right. So this is correct. So we have 2 by 3 equal to minus 3 by p. So cross multiplication 2 into p is equal to 3 into minus 3, which is minus 9. So p is equal to minus 9 by 2. This is the value. Or look at the options. If it says minus 4.5, that is the answer of this question. Alright.